that comes to us from a math competition preparation textbook, I guess. And I just want to make sure we're clear on what we're doing right here. We're trying to find an integer x such that x squared is equal to some multiple of 130. So we'll just write that as 130m. Okay, and also you guys may have seen this divides notation. You can also write this as 130 divides the quantity x squared plus 1. And again, x is an integer. Okay, and this divides, vertical bar just means divides with no remainder. All right. Okay, now the prime factorization of 130 is important, and I have it done for you right here. It's equal to 2 times 5 times 13. 10 times 13 is certainly 130. Okay, and what I did, folks, I couldn't think of anything clever here, so I just did this in a kind of a case-by-case situation. I wrote it in terms of congruences. This means 2 divides x squared. Okay, let me just right above here. I won't write it all out, but this is the same thing as saying 2 divides the quantity x squared plus 1. It's just we're taking advantage of modular arithmetic here to some extent. In similar statements for all the others, okay? So in order for this to happen, 2 has to be a factor of x squared plus 1, 5 has to be a factor of x squared plus 1 or a divisor, and 13 has to be a factor of x squared plus 1. Now another thing that's actually kind of important here, the fact that 130 is a divisor of x squared plus 1 means that x squared plus 1 also must be a multiple of 10. There's no doubt about that. If you have a divisor that's a multiple of 10, then you must be a multiple of 10 also. Now what I did is I just did this in a tabular format. Obviously I didn't write down all the cases, but I wrote down some situations where it failed. In other words, all 4 of these conditions had to prevail. I didn't show it for 3, but for 5, you can see that 5 squared plus 1 is definitely, that's 26. That's not divisible by 10, right? Okay, and now 5 squared plus 1 is divisible by 13, right? 5 squared plus 1 is 26, and that's divisible by 13, right? But it does fail right here. It needs to end with 0, right, for it to be a candidate here. Now, in a similar fashion, I'll just do a few of these. 7 squared is 49 plus 1 is 50. That's certainly not divisible by 13, right? So we have to rule out 7, okay? And let's get all the way down to, I'm just picking some of these randomly. 11 is the same as 1 mod 5, right? And so certainly this is not congruent to 0, right? Because you can replace 11 with 1 and you get 2. Okay, it's not divisible by 5. All right. And I have a few more here. You guys can check them out. Like I tried 19 also. Now one nice way to see that 19 doesn't work is 19 is congruent to 4 mod 5, and so you would actually get 4 squared plus 1 right here. 4 squared plus 1. Okay, and that means not congruent. It means not divisible by 5. That would be 17, which is certainly not divisible by 5. It leaves a remainder of 1. And I won't work anymore. They're all, you can check some of these if you want, but I had to go all the way down to 47 before I got a case that actually worked. Okay, now notice, we'll go through each of these. 47 is the same as 1 squared, right? And so let me just, so you would get 1 plus 1. Okay, now 1 plus 1 is 2, and it's, so that checks, right? This checks. Okay, now right here, how about x squared? Okay, x squared. Now 47 leaves a remainder of 2. Okay, 47 leaves a remainder of 2 when you divide it by 5. Okay, and so right here you would get 2 squared plus 1. Since that's equal to 5, it's certainly divisible by 5, right? That's equal to 5. Okay, now let's check out this one. Okay, 47 squared again. What do we have right here? 47 is congruent to 8. 47, let me write that. 47 is congruent to 8, right? When you divide 47 by 13, 3 times 13 is 39, you have a remainder of 8, right? And so you would have right here, you would have 8 squared. Okay. You can tell I was kind of excited when I got this because I had to check all these and I finally got one that worked at 47. So 8 squared plus 1 equals 65, right? And 65 is certainly divisible by 13, right? 5 times 13 is 65. So you see this one checks. This one checks, this one checks. And certainly, let's check it out right here. Does it leave a remainder of 0? Well, again, that would be 7 squared plus 1 right here, right? And that definitely ends in 0, right? Equals 250. And that's the point of doing congruence, congruent to 0 mod 10. That means 0 is the last digit. Okay. So you see how all of these check, folks? So that's pretty cool. And what if you're dying to know, if you do the arithmetic on this, what this means is that 47 squared plus 1 has to be a multiple of 130. Now 47 squared plus 1, and this is arithmetic you could do in your head if you have to. I did double check it with a calculator. 47 squared plus 1 is 2209 plus 1, which that's 2210. All right. Now 2210 happens to be divisible by 130. Okay, 130 times 17 is 2210. Okay, so we have that this is equal to 17 times 30. There we have it, folks. And as far as I know, that's the smallest one. Now, I checked these others. I didn't show. I very well may have missed something because it's a lot of computations. And I'm not claiming that this is the best way to do it, but it is a way. And it just said, the guy, Harm Derksen, just said, find an integer x. Well, 47, x equals 47 is the answer here. Or at least it's one of the answers. There's bound to be others. Okay, but x equals 47 gets the job done. And that's what he called for, I think. Find an x such that right up here you would get x equals 1, x equals 47 gets the job done. Okay, folks. Hope you enjoyed, and thanks to Mr. Derksen here. I don't know who he is. Has an interesting first name, probably was bullied in school. But thank you for the problem, Harm.